Hello and welcome to Patch Math, where today we are going to continue patching your math knowledge over systems of linear equations. We are focusing on special cases, and today we are going to look at the elimination method. Now, I do want to go ahead and discuss, we did do this problem in the last video, but we did it with the substitution method. And if you're one of my students, you know I like to give you what I call the path of least resistance. That means the fastest method. Generally, I am not a big fan of that. However, my goal is to prepare you for the SAT, ACT, and all those horrible timed exams I know you're going to have to take. So I wouldn't be doing my job correctly if I didn't show you that fastest way. So if you've been with me so far, you already know the answer to this, but the pathway was different in the last video. In this video, we are going to use the elimination method, and we are going to use what I call multipliers, or commonly called multipliers, not just me, in order to modify these equations to get the coefficients to cancel out. Looking here, I see that I have a 2x and a negative 5x. I'm strategizing. Okay, just telling you what I think about. I got 8 and a negative 20. Which of those would be easier to get the same coefficient? I'm like, oh, my x's would be, because they're just smaller and easier to work with in my head. I look at the first equation and I see that I have a 2x. I could go ahead and multiply that by 5 and get a 10 there. Now, my goal is to get opposite signs because I like to do my elimination method by adding the equations. And so I'm going to multiply this one by a positive 2. If we go ahead and distribute each of those over, we're going to find in the first equation, sorry I scrunched that 5 in there, that is 5. And if you are one of my students, you know I write with a mouse, and my handwriting is terrible on the whiteboard. But you should have saw it 5 years ago when I first started working online. We have 5 times 2, which is 10x. We've got 5 times 8, which is 40y. We've got 5 times 6. I'm going faster than I can write here. We've got 5 times 6, which is 30. And this is where I go through and double check to make sure I got everything right. Looks good to me. All right, moving on. We will go ahead and distribute that too. So we have the negative 10x. We've got the negative 40. And we've got the negative 30. And now watch what happens. This is why elimination method is so much quicker than the horrible substitution. Excuse me, than the horrible substitution method we just did. 10x minus 10x is 0x, so that cancels to 0. 40y minus 40y is 0, so that cancels to 0. 0 plus 0 is 0. 30 minus 30 is 0. We get 0 plus 0 equals 0. In other words, 0 equals 0. We ask ourselves, is this a true statement? The answer is yes. So 0 always equals 0. As a result, these are the exact same line. They have infinite many solutions. Exact same line, or two lines that are exactly the same, intersect for every single point. Now, if we go ahead and zoom on out, the graph in the last video is the same graph for this. If you look, all right, that is the same line. Notice the pathway was different in the last video with substitution. Also, notice the length of this video in the last one. This one's a little over 3 minutes. The other one was a little over 7. So on the SAT, that takes a big difference in achieving the exact same answer. So these are points of intersection, aren't infinite many, on this problem. Your math knowledge has just been patched on the elimination method and special cases concerning systems of linear equations. Thank you so much for your time.